Hi student, in this video we're going to solve a problem from the chapter straight line. This is a IIT JEE advanced problem appeared in the year 2014. Let's go ahead and first understand the problem statement. So here we have a point P and we have two straight line x minus y equal to 0 and x plus y equal to 0. Now we need to find out a region R consisting all of the point P in the first quadrant, satisfying the inequality d1 plus d2 is lies between 2, 2 and 4, where d1 and d2 are the distance of the point P to the line x minus y equal to 0 and x plus y equal to 0. Let's go ahead and solve this problem. So let's go ahead and consider first the two straight line which is given as x plus y equal to 0 and x plus y minus y equal to 0 and x plus y equal to 0 and rename them as equation number 1 and equation number 2. So now let's find out the point P. So here we consider the point P as HK and we put a constraint here that it lies in the first quadrant. So therefore H and K must be greater than equal to 0 in first quadrant. That's very obvious. Now let's go ahead and find out the perpendicular distance of a PHK towards the line 1. How we find the perpendicular distance? For that, we need to find out the relation of a line where perpendicular distance from the point x1 y1 to the line ax plus by plus c equal to 0, which is given as ax1 plus by1 plus c divided by square root of a square plus b square. Now if we compare the ax plus by plus c equal to 0 with the line x minus y equal to 0, we get a is equal to 1, b is equal to minus 1 and c equal to 0. So therefore we can find out the distance d1p is equal to h minus k mod divided by square root of 1 square plus 1 square, and hence we can get it as h minus k mod divided by root 2. So that's the distance d1p. Similarly, we can find out the distance d2p from the line P from the point PHK towards the line 2. So here we can see that my A will be equal to 1, B will be 1 and C will be 0. So using the same relation or same formula, we can find out D2P is equal to H plus K divided by square root of 1 square plus 1 square, and that gives us H plus K divided by root 2. So now we've obtained that distances as D1P and D2P. Now we need to find out the sum of the perpendicular distances. So what's that? Let's go ahead and write down it together, right? That's a very simple step. Now let's go ahead. So in this particular problem, right, we need to find out the values or the relation between HK, or in some form we can say the locus of the point HK in such a way that it lies between 2 to 4. So let's go ahead and consider the inequality. And therefore, we can rewrite the inequality based on whatever we proved in the earlier step. Let's just multiply both sides by root 2 to simplify it, right? That's it. So here see that we get a relation between H and K, but mod sign is involved. So therefore, right, we have to play with this mod little bit, right? Because when we have a mod, right, we have to use the definition of mod, right? So that's the only step it's pending now. Let's go ahead. Right. Now here, right, what's our aim? So my aim is to find out the region satisfying the condition whatever we obtained here, and with that H and K greater than equal to 0. So we have to mark or identify or shade this particular region, right? That's it. Let's go ahead. Now observe that here, as I said, we are having the mod function. So first we consider the definition of mod function. So what is the definition of mod x? It's equal to x when x greater than equal to 0 and minus x when x less than 0. Now in the case of mod of h minus k, right, we just replace x by h minus k. So therefore it will be equal to h minus k when h minus k is greater than equal to 0, or h is greater than equal to k, and in other way it will be minus of h minus k, that is k minus h, when h minus k is less than 0, in other ways h is less than k. So that's the definition of mod h minus k. And observe that as h plus k, right, here h and k both are positive, so therefore h plus k is always positive in first quadrant because we are looking this our solution in first quadrant only. So therefore you can say that, right, that mod h plus k, always we will use that as h plus k. That's it. Now let's go ahead and simplify that. So first we consider the case 1 where h is greater than equal to k and try to find out the values, right? Values of the function, that is mod of h minus k and mod of h plus k. So here we consider that, right? So here mod of h minus k will be replaced by h minus k and h plus k is always h plus k. So see that k is cancelled from the both sides. So therefore 2h is lies between 2 root 2 and 4 root 2. Dividing to both sides, it will be root 2 and 2 root 2. That's very simple arithmetic, right? So therefore you understand that if h is greater than equal to k, then h must be lies between root 2 and 2 root 2 to satisfy the given inequality. Go ahead and consider the case 2 where h is less than k. So here my relation mod of h minus k will be replaced by k minus h and the remaining h plus k will be as it is. So now here h get cancelled and 2k lies between 2 root 2 and 4 root 2 and hence k lies between root 2 and 2 root 2. So therefore, we can rewrite our required region in this way. So when h is greater than equal to k, right, then case 1 states that, right, my h must be lies between root 2 and 2 root 2. So this is the region we have to locate it. But we have a constraint that h is greater than equal to k. For case 2, when h is less than k, then our region will be root 2 to root 2, but here for k lies between that. So this is the required region we have to find it in. So let's go ahead and try to locate it in a coordinate axis so that we can visualize the region. Let's go ahead. So here, see that we have the condition of h greater than equal to k. Now see that, right? What is h greater than equal to k? Obviously, we can draw a line. So here to draw that line, we draw two mutually perpendicular axes, namely h and k. So we draw that as h, the horizontal line, and the vertical line or vertical axis as k. Draw a line which is h is equal to k. So it's a line passing through the origin with a slope 1 so that we can easily go ahead. Now obviously here this line h equal to k divides the first quadrant in two parts, region 1 and region 2. So this is region 1 and the next one is region 2, right? In region 1 it is obvious that, right, h is greater than equal to k, and in region 2 h is less than k. If you don't understand that, take a arbitrary point in region 1 and region 2, check for the coordinate and get it done. Let's go ahead. So how? Now here, right, it says that in the region 1, inside the region 1, our main region, right, that means the required region R is actually lies between, right, root 2 and 2 root 2, and it is h equal to 2 root 2 and h equal to root 2 is a vertical line. So therefore we draw the two vertical line, h equal to root 2 and h equal to 2 root 2, and then the required region obviously will be inside that thing, right? So therefore the intersection of this region will give us a trapezium, right? So ABCD, right, which is represented the region here, right? Now let's go ahead. It is a trapezium, obviously. Now see, here we have some coordinate, right? Let's mark this coordinate. So the point B, it lies on that h axis. So therefore, the coordinate of the point B will be root 2 comma 0. C 2 root 2 comma 0. D, it will be obviously that x coordinate is 2 root 2 and y coordinate will be 2 root 2 because it lies on h equal to k. So therefore by this process we find a is equal to root 2 root 2 and all those particular values, right, because which is required to find out the areas, right? That's it. Now our case 1 is done. Now we have to locate or mark the region 2, right, in that region 2 where h is less than equal to k. So therefore in region 2, if we consider here k lies between 2 to root 2. What is k equal to root 2? K equal to 2 root 2. These are the horizontal line, and obviously these lines pass through the point A and pass through the point D, right? So we draw that region, right? Now here also we get a trapezium, right? So let's mark that region between these two lines. So that trapezium will be defined by ADEF. So therefore the required region, okay, are actually given by the sum of the two region trapezium ABCD plus the trapezium ADEF, okay, and together with and together with this represent the region R. Now our job is to find out this area. How we go ahead and find out these areas, right? We know the area of the trapezium. It actually gives us sum of the parallel side 1 by 2 sum of the parallel side multiplied by the height. So therefore the area of the trapezium ABCD will be 1 by 2 AB plus CD multiplied by BC. Now look at that. From these coordinates we can find out all those values here. So here AB is equal to root 2, BCD is equal to 2 root 2, and BC is definitely right 2 root 2. So therefore we can find out these areas is 3 unit. And we need to find out now the area of the trapezium ADF. In the similar manner, we can calculate the area is A plus D into EF. Here also we can find out that what is the value of A, that root 2, D is 2 root 2, and obviously EF is root 2. So the area is also 3 here. So therefore the total area R, or the region of the area R, are actually 6 units. So therefore for this problem, the fill in the blanks kind of thing, here we have to write down the right option as 6, right? That's it. So that's the answer. Hope you understood it.